All right, looking at this tape on ratio and proportion, first let's talk about what a ratio is. As in the notes, it says a ratio is a comparison of like quantities. A comparison. Now it really doesn't have to be like quantities, as I'll show you a little later in the tape, but it is a comparison where you compare two things to each other. So let's look at the first problem in the notes. It says 5 years compared to 10 years. Write the ratio of 5 years compared to 10 years. So ratio is simply 5 years, and you should learn to not just write down numbers but put words with them when we start working with ratio and proportion, because it's going to be crucial in the stated problems that you pay attention to the words. All right, so here's the ratio. 5 years to 10 years, and then we can reduce that. If I divide 5 into that, it'll go 1 time, 5 will go 2 times. Therefore, we say the ratio of 5 years to 10 years is 1/2. Or we say 1 to 2. The ratio of 5 years compared to 10 years, the ratio of that is 1 to 2. Now, there are two other ways of writing ratio that you need to know in case you run across it on an exam or a teacher talks about it that way. And that is, the second one is you put the 5 years and you put colon here. And then you put 10 years. So that ratio is 1:2. Or we just come along and say what we've been saying all along, and that is simply the ratio is 1 to 2. So here are 3 different ways of writing it down on paper. So some tests and some teachers might write this one, some might write it this way, and others might write it that way. You just need to know that they're all the same thing. But a ratio is simply a comparison in a fractional unit of one object to another object. All right, let's look at number 2. Number 2 wants the ratio of 15 gallons compared to 25 gallons. All right, so what we have is 15 gallons compared to 25 gallons. All right, and then you should reduce that. All right, 5 will go into this 3 times. 5 will go into this 5 times. So therefore our ratio, our comparison of 15 gallons to 25 gallons is 3/5 or 3 to 5 or 3 to 5. But all of those are read the same way. Really, when you're reading them, you say the ratio is 3 to 5. The ratio is 3 to 5. The ratio is 3 to 5. Okay, let's look at number 3. And here's where the words become important. Okay, it says compare, write the ratio of the comparison of 18 feet to 2 yards. So we have 18 feet to 2 yards. Well, now in most problems, not all of them, but most problems, you usually write ratios with the same units. And that's what you want in terms of the word ratio. Now, again, we're going to look at proportion a little later, And in that one, we don't have to really change it to the same units in all problems. But if we want the ratio of 18 feet compared to 2 yards, what we should have are to have the same words here. So what we need to do is to change it 18 feet to feet. Well, 1 yard is 3 feet, so 2 yards would be 6 feet. So the comparison of 18 feet to 2 yards is actually 6 going to that 1 time, 6 going to that 3 times. The ratio then is 3 to 1. All right. Now, notice then that we change the yards to feet. Let's say that we are going to come back up here and change it to yards. Okay? Well, 18 feet. 18 feet. How many yards is that? Well, 3 feet is 1 yard. So if I divide 3 into that, I get 6 yards is to 2 yards. And when I divide this into that and that into that, I still get the ratio of 3 to 1. So it doesn't make any difference which words you change. It's just that a ratio is supposed to be having the same words. Okay. So you need to watch for that and not get caught on an exam where you'll come along and just put 18 to 2 and get 9 or get 9 over 1, and then they'll have in the answer a 9 over 1 and a 3 to 1, and you'll pick out the wrong answer. So when you're doing a ratio, make sure you get it to be the same words. Then reduce it, and then whatever you have here is the ratio. Okay, let's look at number 4. Looking at words now in a sentence, and it said, last week, John ate 10 hot dogs while Bill ate 25. What is the ratio of Bill's hot dogs to John's? Now, wait a minute. You got to read the sentence, and not just slap down numbers again. It says, what is the ratio of Bill's to John's? So that means Bill's goes first or on top. So that would be 25 to 10. Okay, and then you divide 5 into that, it'll go 5 times, and 5, that'll go 2 times, and so therefore the ratio is 5 to 2. But again, in the stated problems, make sure that you understand that you pay attention to which one comes first. If it says, what is the ratio of Bill's to John's? Okay, 5 to 2. Okay, then that means ratio is simply a comparison, a number divided by a number. But the important thing to remember, you must have the same units, the same words to go with it. All right, let's look now at the second page of your notes at what is called proportion. Now, proportion is simply 2 ratios that are set equal. 2 ratios that are set equal. So looking at the first one there underneath proportion, we have the ratio of 1 to 2 is equal to the ratio of 2 to 4. Okay, how do we know for sure that's correct? Well, one way is to do that cross multiplying. That's 4. And multiplying here is 4. And so therefore, those 2 ratios are equal. All right, look at number 2. Is this a proportion? Is this a proportion? Well, yes, it is. If this times that, so that's 168, and this times that, is 168. So if those are equal, then those two ratios, the ratio of 3 to 8 and 21 to 56, are equal. Therefore, that makes it a proportion. All right, now, let's go to number 3 and look at what we deal with. Here's number 3. Now, notice the words aren't the same. The words aren't the same. But if, when you cross multiply, and these give you the same answers, then it's okay to use that. So here's what I'm saying to you. You can write a proportion this way. We can write 15 miles is to 30 miles. What I'm doing is switching this down here, and as 2 gallons is to 4 gallons. They have miles to miles, gallons to gallons. And notice the cross multiplying are the same numbers. It's still 4 and 15. And multiplying here is the 30 and the 2. So when you write proportions, here's the key. In proportions, you can write miles to miles, same words equals same words. Or if you put miles to gallons, then over here on this side you must have on top the same word, and on the bottom this same word. So proportions then can be written either way in terms of the ratios. We can have same word to same word, and usually that's the best way to do it. It's not the only way. Equals same word to same word. But if for some reason in working a stated problem you want to put down this over gallons, then you must over here put the same word on top as you have on over here on top, and you must put the bottom word the same as the other bottom word. Okay, let's look at number 4 on proportion. And all this is saying, well, look, we have a proportion problem here, and we want to find what this is. We don't know what this should be to make that proportion work out. So this says that 3 miles is to 5 miles, as we don't know how many miles is to 10 miles. 3 gallons is to 5 gallons, as we don't know how many gallons is to 10 gallons. See, so we're going to get to some stated problems now after this problem, where we're going to have to find a missing part of this. All right, so what we do is we cross multiply. That would be 5x, and that would be 30. And so now we divide both sides by 5, and we get x equals to 6. So that says 3 is to 5 as 6 is to 10. Now this is the way you read a proportion. Now in some books, in older books at least, and every now and then somebody will use this, they used to use 4 dots. And you read this as 3 is to 5 as x is to 10. Okay, remember, ratio is 3 to 5, 3 to 5 as x to 10. And then to solve it, you cross multiply. All right, let's do now is let's work a bunch of stated problems using proportions. All right, looking at number 5 here, it says how many gallons of paint will have to be purchased to cover 5,500 square feet of surface if 2 gallons will cover 700 square feet. You know, one way of doing this would to say, well, now how many of those 700 square feet is there in 5,500 square feet? And if I figured that out, then I'd just say, okay, I'll multiply that times 2 gallons. And that's a way of getting the job done. And that's probably the way most of us reason when we go into a store to make that kind of decision. But proportions will give us a way of doing it mechanically and accurately. And here's how it works, okay? It says that for 2 gallons, we can cover 700 square feet. So what we'll do is say, come over here and we'll say, well, how many gallons? That's our unknown. We'll cover 5,500 square feet. In other words, if you know a ratio, we have given a ratio of 2 gallons compared to 700 square feet. So we'll write that ratio down, the ratio of 2 gallons to 700 square feet. Then we come over in a proportion and say equals, and then we write gallons to square feet. If we have gallons on top, then we have to put gallons on top over here. And that helps us know whether the X goes up here on top or whether it goes on the bottom. And that's all there is to setting up a proportion from a problem. Now to solve it, we use this cross multiplying. Okay, so multiplying that would be 700x. Multiplying this would be what? 11,000. Now we divide, to solve for x, we divide both sides by 700. And so x comes out to be 15.7. Now wait a minute, 15.7 what? We'll go back up here. X is gallons, so this is gallons. So approximately you would have to buy 16 gallons to be able to do that painting job. All right, now let's look at another way of doing this in terms of getting same words to same words. I could, in this problem, come back and say, well, I want the same words to same words. Then it says, how many gallons to the 2 gallons that I have will cover, all right, now wait a minute now. The 2 gallons covers what? 700 square feet. And the X gallons is supposed to cover the 5,500 square feet. Now this is where, again, you'll foul up if you're not careful. If I come over here and say X gallons to 2 gallons, in other words, how many gallons do I need if 2 gallons covers something? So if I put the X up here, then the X has to go with what it's going to cover. So the X gallons is what we need to know to cover the 5,500. The 2 gallons covers the 700. Now, if you notice, when you cross multiply here again, you get the same numbers. And so you go through the same work. So if it's more comfortable for you to put the same words over the same words, then do so. But the catch then is when you put the same words over the same words, you have to put the connection of comparisons this way. The comparative sentence was 2 gallons will cover 700 square feet. So those two have to go together, and up here, the unknown gallons to the 5,500 square feet. All right, so now let's look at number 6. Okay, a car uses 8 gallons of gasoline. For a trip of 192 miles. How many miles could the car travel on 20 gallons? Well, again, most of us would say, hey, 8 gallons, I'll divide that into 192 miles and then see whatever that's equal to. And then multiply by 20. Okay, that's kind of the way we reason it. But again, what I want you to understand is ratio proportion helps us to work that out accurately. All right, so we're going to come up here and we're going to say, well, 8 gallons gives us 192 miles. So what does 20 gallons do to miles? Again, I have gallons to miles. Then if I have to put gallons on top, miles on the bottom. Okay, cross multiplying, I get 8 times x. And multiplying here, I get what? 3840. Okay, then dividing both sides by whatever it is times the x. Whatever's times the x, you divide both sides by. And dividing that, 8 will go into 38 4 times with 6 left over, so that's 480. 480 what? Go back up here, it's x what? Miles. So that means this is 480 miles. Okay? Or, if, again, we want to put same words to same words, and if we did it that way, then what we would do is to put 8 gallons is to 20 gallons as what now? What connects with 8 gallons? We know that to be 192 miles, and the 20 gallons is what we're looking for. But again, if you cross multiply, we get 8x. Cross multiplying, we get 3840. Same answer, same numbers, and so it doesn't make any difference whether you put same words over the same words. The key, though, is when you put same words over same words, and this is the connection of your comparison, your ratio, and this is your connection. All right, let's look at a little more difficult one in terms of the numbers, but the same process. Okay, number 7 says on a map 2.5 inches represents 100 miles. How many miles does 12.5 inches represent? Well, see, this is not quite as easy. And so instead of sitting there and trying to think and figure out shortcuts and stuff, then all we have to do is write this down and it'll work out. Okay, so what we'll do is put and say 2.5 inches gives us 100 miles. Then how much does 12.5 inches give us in terms of miles? See, the sentence says 2.5 inches represents 100 miles. That's a ratio. 2.5 inches over 100 miles. So we come over here, and if we have inches on top, then we have to put inches on top. Miles go on the bottom, miles go on the bottom. What are we looking for? It says how many miles. So the x goes in front of the word miles. And then we cross multiply. This times that is 2.5 x, and this times that is 1250. Okay, and so now we divide by 2.5, divide by 2.5, and so x comes out to be 500. 500 what? 500 miles. Again, looking at your notes, I'm not going to do it on the tape, but looking at your notes, you could have put